Welcome to this online presentation of the Mpai call for technologies for connected autonomous vehicle technologies. Briefly about the MPAI, we are called the Moving Picture Audio and Data Coding by Artificial Intelligence. We are an international unaffiliated nonprofit standard developing organization. We develop standards for AI-enabled data coding with clear IP guidelines. So far, we have produced 11 standards and other documents, and we are about to publish a new one. 5 of our standards have been adopted by IEEE as IEEE standards, and more are to come, and I will say more in a minute. Developing standard with a rigorous process is mandatory. And in Mpai, we have a process that is divided in 8 stages. And to progress from one stage to another is rule. We need to have an approval of the Mpai General Assembly. These are the standards that we have produced. As you see, we have in the first column a kind of categorization. We have system standards, audio standard, and automotive standard, finance, human machine communication, metaverse, watermarking, object and scene description technologies, and portable avatars. The red one is the standards. It's the name of the project, and we have already one standard that is called architecture, the one that you're seeing here. And we're about to launch the new project on technologies, which is what we are talking about today. Other projects are about to become standard at different times. We have one AI module profile that will become very shortly a standard. We have in preparation one for AI health. We have another on live venues, live theatrical performance in the entertainment domain. We have an online gaming technical report that is being prepared, and we are deeply engaged in the development of the comfort technologies and the functional requirements for 2 video projects. We are launching, actually, this happened on the 15th of May, 3 new projects with call for technologies, one on CAV technologies, another on Mpai metaverse model technologies, and another on connected context-based audio enhancement, 6 degrees of freedom. And all include the call for technologies, use cases and functional requirements, framework license, and template for response. This is what I will do today. This is the 3rd online presentation for connected autonomous vehicle technologies. So, what is the call? Before going details about the call, let me share with you the vision that we have for connected autonomous vehicles. I think that autonomous vehicles can greatly contribute to improving human life and environment. Standards facilitate the conversion of connected autonomous vehicles from siloed system to system made of standard components. And component-based connected autonomous vehicles are more reliable, explainable, and affordable. And Mpai CAV is the name of a project which is actually intends to be a series of standards addressing componentization of connected autonomous vehicles. So, what is the call for technologies? Invites all parties able and willing to contribute to the development of the planned Mpai CAV technical specification to submit a response. If they own technologies relevant to the scope, they will eventually be required to license their technologies according to the Connected Autonomous Vehicle Framework License if their technologies are selected by Mpai for possible modification and inclusion in the planned CAV technical specification. Any respondent who is not an Mpai member and wishes to participate in the development of connected autonomous vehicle shall join Mpai. If they own accepted technologies and do not join Mpai, they lose the opportunity to have their technologies included in the planned specification. What's the scope of this call? So strictly, we have a document that is called Use Cases and Functional Requirement, and that defines the domain addressed by the scope. On the other hand, we are happy to receive comments about technical elements of use cases and functional requirements. And also, if you have technologies that are not specifically requested by the call, but you think are relevant, if they are based on motivated proposal to extend the new functional environment, you are welcome to propose that. But the condition is that they are within the scope of the functional requirement that satisfy the frame or license. Dates, key dates. The call was issued on the 15th of May. The presentation, online presentation is now. Well, it is tomorrow, but you know, that's not a stricter date because this notification of intention to submit proposals is something that we wish very much to receive, but it's not mandatory that you send. Then the deadline for submitting a response is exactly 1 month from now, and the start of the response evaluation will be on the 10th of July. Okay, so let's have a in-depth review of the use cases and functional requirements for connected autonomous vehicle technologies. How do we get there? In the early days of MPAI, a project on connected autonomous vehicle was kicked off. Last year, in September, we published the technical specification Connected Autonomous Vehicle Architecture. In January, this standard was submitted to IEEE, so that's what I was meaning then, that we have more in the pipeline. And now, in May, we have published the Mpai CAV technologies call. So what's the current state of CAV standardization in MPAI? So I have mentioned the Connected Autonomous Vehicle Architecture specification. This is specified the architecture of a connected autonomous vehicle based on a reference model that comprises a CAV broken down into subsystems, for which subsystem we define functions, input and output data, and topology of components. Each subsystem, in its turn, is broken down into components of which functions and input and output data are specified. Finally, each system is assumed to be implemented as an AI workflow made of components implemented as AI modules, and they are implemented in the AI framework. These words are included and actually specified by a standard that is called AI framework. So let's see how this connected autonomous vehicle works. So we have a human approaching the CAV, requesting to be taken home. Here we have the autonomous motion subsystem, one of the system that responds to this, requests data from the environment sensing subsystem. Then the motion actuation subsystem provides additional information concerning the environment, and finally, the autonomous motion subsystem integrates the understanding of the environment by connecting with other cabs or CARES-enabled device like a roadside unit to improve and achieve a complete understanding of the environment. Then, based on that, the cab is ready to issue a command to the motion actuation subsystem to move the cab for, say, the next 50, 100, 200, depends on how many meters it can, it feels confident to be able to drive the cab. So now I'm going into some details of the force subsystem. This one has actually already been specified, but we are certainly happy to hear more comments about this. So imagine that we have text, of course, humans still communicate with text, audio, LiDAR, visual information coming into the audio-visual scene description. This is called AI module, what I mentioned before, that produces speech objects and audio-visual scene descriptors. Based on that, it's possible to get a recognized text. Then we also get the visual scene descriptors and the visual object identifier that has been created by this AI module. All this input come into an AI module that is called natural language understanding that provides the text and the meaning of the text. And then we have from the audio-visual scene descriptor, we have speech objects that are passed to this speaker ID identification, and similarly, we have face objects that are passed to face ID recognition AIM. The personal status extraction is an important element in the conversation between humans and cabs. The result is essentially that we have meaning, text, we have the personal status. The personal status is a very important element, which is describe how the human feels internally. And so we have many ways, we humans, to understand this personal status to a certain degree, and we want and we are specifying this unit which is called the human-machine interaction, such that the machine has an understanding of the personal status of the human. Then we have also other important element, which is called the visual object ID. So here, all this information goes into an AI module that is called entity dialogue processing, which is able to provide a response in text, but not only that. It also provides its own simulated personal status, and these two information flows are passed to an AI module that is called the personal status display that creates a data type specified in Mpai that's an avatar, but it is what we call the portable avatar that can then be rendered for humans to perceive by the audio-visual scene rendering. So this is not the end of the story, because we can have humans in the cab who are requesting the cab to provide what they see as the outside environment. So you see that we have here something that is called full environment descriptors, which is the best understanding of the environment that the cab has, and it also specifies from where the user want to see the environment, and that information is passed again to the audiovisual scene rendering that is able to produce the required information. There's one other important point that we have to say. So there's something here that is called remote HCI. So HCI is the human cab interaction. And so these two entities can communicate, and we would like to specify a first set of messages that are useful for this HCI to improve the value of the cab. Then we have, again, the autonomous motion subsystem, and this is used when for instance, the cab is asking the cab to take them home or to go to a particular place. Then the autonomous motion subsystem will respond, and again we have a set of messages that we would like to specify. Let me go now to this table, which of course is rather dense. This is the table of the data types that are used by the human-cab interaction. As I said, we already have a standard for that, and we are actually developing a new version of that standard. This is the another subsystem. This is the environment sensing subsystem. Again, it is rather complicated, but essentially we have an AIM that deals with audio information, another that deals with visual audio information, with radar scene information, LiDAR scene information, ultrasound, and also we have offline maps, because these are certainly useful for the cab to improve its understanding of the environment. Of course, we don't assume that a cab has all these technologies, but we wanted to be able to cover the cases when a cab has, say, visual, for instance, then also uses some ultrasound. So ultrasound is a valuable source of information, so why should not be able to use it? Then we have the traffic signalization description that on the basis of the understanding of the environment information extract what is the traffic signalization of the environment. All this information is passed into this big AIM. It's big in the sense that it has many inputs. It integrates all the scene descriptors into one descriptor, which is called basic environment descriptors. Alert is a subset of the basic environment descriptors that are passed for a high-level intervention by the autonomous motion subsystem. So here we have again another long list of data. Of course, they are not all the same, because the basic environment descriptors, this is something that is used by all. But now let me go to the next stage, which is the autonomous motion subsystem. So here we have information coming from the environment sensor subsystem, which is exactly what we have already seen, that provides the basic environment descriptors, and the full environment description AIM will do its best to do more, and particularly it will request other cabs in range if they can provide additional information about the environment. Then we also have, as we already have seen, the human-cow interaction, where there's a request about doing something, and here we have a response to do something. And then here we have the chain of actions that will lead to a command to the motion actuation subsystem to move the car. So we go through a path selection to motion selection and traffic obstacle avoider. Traffic obstacle avoider receives this alert information because this is the last check that is done about the viability of the information that it has and the action of issuing a command. Then we also have a decision recorder that recorded the decision about the route selected, the paths selected, the trajectory selected, and the commands and the response from the motion actuation subsystem. So this again is the set of data types. Again, many are duplicates because they are needed in different places. Finally, we go to the autonomous motion subsystem. So this is simpler in a sense, in the sense that we have a lesser number of AI modules, but we have one that produces a first assessment of the position. Spatial attitude is position, orientation, and velocity and acceleration. This is a data type that we have defined in MPAI. It has information to do that. It has auto metadata, speedo metadata, accelerometer data. It also adds other environment because like humidity or temperature and so on. So this is the autonomous motion subsystem. So it is outside, of course, of the subsystem. And it provides messages to an AIM that is called AIM's command interpreter. So the autonomous motion subsystem will say, now go straight for 100 meters and then turn right. So this request is to be translated into actual motor command, steering command, and brake command. Then, as a result of these commands, the different devices here that are not part of the cab, so we only have the interfaces, there will be a response from the motor, response from the steering, and response from the brake. That will be integrated, analyzed and integrated into a message that is sent back to the autonomous motion subsystem. Here we have the usual list of data types. So it is now time of summarizing what we have said so far, which is what is the scope of this call and of the standard that we intended to develop. To specify the JSON syntax and semantics of all data types. To identify the formats that are used to represent the different data types. To identify the attribute that can be attached to the data types, and identify the format used to represent the attribute. And the scope of the call is to request a proposal for technology used to represent the data types and attributes. So let me go now to one. This is just one slide, but it is connected to a larger source of information, because here we have the names of 3 subsystems. So here I did not put the human CAV interaction, because as I said, it's already standardized, even though we are keen to hear more from you. So for instance, we have audio scene description. So this is the AIM that provides a description of the scene that is based on the audio information. So let's see what we can find here. So this is the standard set for all these AI modules. We say, what's the function? Is to receive this data and to produce the audio scene description and alert information. Then this is just a very simple graph picture that represents what is in this. So we have the input audio and we have also the spatial attitude, because we have to know where in the environment all these objects are placed, and the output is the audio scene descriptors and an alert. But the audio scene descriptor has the capability to request access to the basic environment descriptors, which integrate the information received from all sensors, but at previous times, in order to refine the audio scene description. Here we have the list of input-output data, and we have so we are saying that there are no sub-AIMs, and this is the JSON metadata of this AI module. So this is done according to our format. So here we have the ports, and then so here we don't have sub-AIMs, but in other cases we do have sub-AIMs. Of course, I could go through all of these modules, but I believe that you have understood and also understood what we are actually requesting. This is another dense page, because it refers to the data types that are across all AIMs. So here you have the human CAV interaction and the environment sensing subsystem. Then you have the autonomous motion subsystem and the motion actuation subsystem. So let me go a few. So this is, so the description of the audiovisual scene is very important. And so here is how this is specified. So we have a definition of what it is, the functional requirement, the syntax, and the semantics. Okay, so this is all that we have. And here we are saying what we are asking. We are no specific data format, but we are asking you to review these JSON syntax and semantics. The syntax, let's have a look. So here we have a header, then we have the idea of the descriptors, how many objects there are in the scene, then the position, the audio objects, then we have the visual objects, and then we have the audiovisual scene object, because in some cases we only have the audio component or the visual component. In other cases we have an integrated place, so that is what it is. And then here we have the possibility to express a scene as a composition of scene. You may ask why a CAV should need that. Well, it can, because if it is communicating with another CAV, not necessarily the CAV should send again the information that is sent before, if that is part of a static part of the scene. So this is what we have in terms of audiovisual scene descriptor. And then I could go through many other of these. So here we have the radar scene descriptors, we have the LiDAR scene descriptors, ultrasound scene descriptors. We have the offline map scene descriptors. So the idea here is that the offline do provide a very detailed, maybe at centimeter level, a description of the environment, but it is a static description because this map is updated only at a certain time. But it's very important to be able to convert that offline map scene descriptor into a standard format that is used by the CAB and used to create the final description of the entire scene. So here we have for the autonomous motion subsystem, the motion actuation subsystem. There is also always the same structure and also always the same structure of request of what we are expecting you to respond to the call. So let me have, it's only one slide, but I think it is quite important. And this is about what's the relationship with the metaverse with connected autonomous vehicle. You may say that, well, metaverse is, well, somewhere in a virtual space, the connected autonomous vehicle is very much down to ground. Yes, but a cab uses sensor to acquire data from the environment and uses that data to create a representation of the environment. And that is a virtual representation. And we call that basic environment descriptors. And this is represented by audiovisual scene descriptors, plus a few other data like that related to the, say, to the environment, like temperature and so on. Now, a cab exchanges portions of its audiovisual scene descriptors or its basic environment descriptors with other cabs. And of course, it cannot send megabytes of data because there may be many other cabs in the same place, and they are also the network is used not only for traffic but also for other purposes. So in any case, this means that the format of the basic environment descriptors should be scalable in the sense that I can send some very, very rough information that is still useful. Maybe just the bounding boxes of the vehicles with their positions. That's already vital information for another car. Or if you can afford it because there's not much traffic in the network, then you could send them more and have a more reliable transmission of information. In any case, a cab eventually produces the full environment descriptors, and that is yet another version of the audiovisual scene descriptors. What we intend to do is to use the same technology that we have specified for the Mpai metaverse model for cab purposes. And by the way, we have a parallel call for technologies for the Mpai metaverse model. So the two projects will advance together. So that concludes the bulk of this presentation, which was the use cases and frame of license, and the use cases and functional requirements. Now we address the frame of license. So what is the frame of license? It is a description of the conditions or the guidelines concerning the development of a final licensed by patent holders. So the standard may include also technology from other bodies or other specifications. So what are these conditions? So this is it's very, very general, but in some sense there is quite some substance. First of all, that it should be in compliance with the principle of competition laws. That's clear. That the license should cover all the IPR that is needed from a licensor in order to practice the standard. And this should be used for development rights and implementation rights. The license will grant access to essential IPR in a non-discriminatory fashion. The scope of the license may be subject to legal, bias, ethical, and more limitation. The royalties will apply to all profiles, any implementation on a worldwide basis, of course, and an implementation of the standard may use, as I said, other IPR that to extend the implementation by providing other functionalities. Here you have some cases where you don't need an implementer does not need to pay for a license. Then there's point 8, which is quite important in the sense that when the standard is approved, the holders of patent essential, standard essential patents will express a preference on the patent pool administrator. Finally, so this is probably more focused. So the license will be issued before commercial implementation of the standard become available on the market. The total cost of the license will be in line with the total cost of the license for similar technologies standardized by other standard development organization, and the total cost of the license will consider the market value of the standard essential patents. So this is the collection of guidelines based on which the patent holders will develop a license. Here's the template for responses. This is provided to help people who wanted to respond to the call and have doubts. Well, what should I write there? Where? What exactly do we need? So it contains a template that I believe is quite useful for people intending to make a response. Now, with this, I think that we look forward to working with you on the exciting CAV technology project. So this is our logo, and I invite you to join Mpai and share the fun and build the future. And here you will find more information about this. In particular, you will find the links to all the pages that I just shown a couple to you, but there are several tens of these pages, which is quite important and are basically an essential component of the standard that we intend to develop and for which we are calling for technologies. Thank you for your attention.